Hi class, this is Neil, and this is the last part of lesson 8. So we're going to review the last example problem that you can then use to answer the questions in the handout. All right, so in this last type of problem, we're going to be looking at what happens when we just change the variable type entirely. So by that, what I mean is our variable originally might be given to us in years, so we'll have a year variable, and the problem will say rewrite the equation with a month variable, or a week variable, or a day variable. It actually makes part of the problem a little bit easier for us. All right, so let's look at this example. So we have here a study of black bears in the Adirondacks reveals that their population can be represented by the function p of t equals 3,500 times 1.025 raised to the t, where t is the number of years since the study began. Which function is correctly rewritten to reveal the monthly growth rate of the black bear population after m months? Okay, so notice our variable here changed from where t is the number of years to where m is the number of months. So that actually makes part of the problem a little bit easier for us. All right, so we're going to start the problem the same way. So we're going to make our little graphic organizer for our rate. So our original rate is 1.025. Oh, let me erase that. All right, so again, let's just make a note of what we're doing here. We're going from years and we're changing it to months. All right, so to do that, a month represents really 1/12 of a year. So I'll take that 1.025. I'll raise it to the 1/12 power. Again, I have to use a calculator app or a calculator on my phone or Desmos to do that. And when I do that, I'm going to get this decimal 1.0020598. Now, for our exponent, it's actually a lot easier in this problem. We don't have to really think about what we have to do to the number of years, because our original exponent, t, is in terms of years. And when we're changing to months here, the problem defines for us a new variable, that m represents the number of months. So we don't have to do any kind of manipulation with our exponent here. All right, so now we have the information we need to write our equation. So we've got p of t equals 3,500 for the starting amount of bears, raised to the power of 1.0020598. And now my exponent here is just m for the number of months. All right, looking at our answer choices, I can very quickly eliminate 3 and 4. The rate doesn't match up at all. Looking at my options between 1 and 2, 1 would be correct if the variable was still t. It's not t. It's m for the months, so we don't need to manipulate the exponent at all. So option 2 is the correct choice. You can pause the video to write down that example. What you can do now, though, is answer questions 1, 2, and 3, and you'll submit your answer on the Google form. All right, so that concludes this video and this lesson. Please send any questions that you might have through Google Classroom. All right, have a nice day.